Ruhi, over to you.
Thank you, ma'am. Am I audible?
Yeah. Switch on your video also.
Yes, ma'am. Be strong. You never know who you are inspiring. Hari Om. Good morning, one and all present here. Today, we are gathered here for the Student Enrichment Program organized by Computer Department in association with IQAC of Chinmaya Arts and Science College for Women. Now, I would like to invite Anita ma'am, Head of Department of Computer Application, for her welcome speech. Ma'am, over to you.
Thank you, Ruhi. Am I audible?
Yes, ma'am.
Okay. Hari Om, respected principal, the very inspiring academician, Dr. Judy, colleagues, and my dear students. We, Chinmaya Arts and Science College, have been conducting webinars for the students under the banner of Chinarts Student Enrichment Program right from September 2020 onwards, right? During the pandemic, we have started this particular program. And all the sessions were handled by the academicians as well as industry personalities. And today we have with us Dr. Judy, the young professor and academician from Cochin University, Science and Technology. She will be enlightening us with the topic Accelerating Artificial Intelligence with GPUs. Artificial intelligence, as all of us know, that it was invented to augment the human intelligence, or I should say the work of humans, or the potential of the human intelligence. And all the organization, most of the organizations are evolving with artificial intelligence. And not only that, just because of the volume of data is growing like anything, the artificial intelligence has become one of the very, very essential component of all the bigger organizations nowadays. So they want to analyze the data, or they want to extract some knowledge from the data. For all these things, they are using artificial intelligence through the machine learning algorithms. And earlier, if you imagine to perform the analysis on 100 records or maybe for 1000 records, group of people will be working on that, which will take maybe a day or 2 days altogether. Whereas nowadays, lakhs and lakhs of records can be analyzed within minutes by the machine learning algorithm. So that is how the artificial intelligence have evolved now. But not only that, almost all the organizations, especially during this pandemic, we are going online, and almost all the organizations have started collecting various data for various analysis purpose. And all these things are done by some of the algorithms which are completely coming under the artificial intelligence area. And I should say that the artificial intelligence systems are like they are I should say it is all there in the organizations, and it helps in almost all the workplaces, and it works better than the human intelligence also. And it helps in all the cognitive tasks that are done by the human being. And not only that, if I say artificial intelligence is becoming an essential component of the organization, it needs the high power computing environment to do all sort of cognitive tasks. That is where the graphical processing units, GPUs, were becoming very, very mandatory for all the high computing machines also. And when all of you are very much familiar with the central processing unit, but the graphical processing units were used only for the graphical processing earlier, but now the GPUs are used in almost all the computational aspects of a computer. And I hope today's session will obviously enlighten you, and it will give you an idea on how the GPUs are used in the artificial intelligence, and artificial intelligence with machine learning algorithms and data science is becoming one of the very, very popular research area where you can work on. So with this note, let me move on to my duty. On behalf of our department, let me first welcome our principal, Dr. C.R. Lalita, who is always an encouraging and supporting authority of our institution. I welcome you, ma'am. Next, let me welcome, and I have immense pleasure and pride to welcome the young academician, Professor Dr. Judy of CUSAT University. We are really very, very grateful to her in spite of her hectic schedule. She has consented to be with us to share her knowledge and experience on the topic. Ma'am, on behalf of our institution, I welcome you, ma'am.
Thank you.
And I also welcome all my supporting faculty as well as all my dear students to the session. And participants, please see that you keep your mic muted always. And there will be an attendance and feedback form shared towards the end of the session. You have to fill in the form to get the e-certificate. Thank you. I once again welcome all to this session. Thank you. Over to you, Ruhi.
Thank you, ma'am, for your words. Now it's my privilege to invite our beloved principal, Dr. C.R. Lalita, ma'am, for her address. Ma'am, over to you. Lalita, ma'am.
Yeah, I am here. I am here. Hari Om, the young academician, our guest of the day, Dr. Judy from CUSAT, other faculty members, and my dear students. Today we are having the CSEP organized by the Department of Computer Applications. I am happy that the department has chosen such a relevant topic in today's webinar. I hope the students will get many informations about the recent developments about the graphics processing unit. GPU has become one of the most important types of computing technology, both for personal and business computing. It is used in a wide range of applications, including graphics and video rendering. They are becoming more popular in artificial intelligence, and here we are today blessed with a talk on accelerating AI with GPUs. And I wish this program will become a successful one. Thank you.
Thank you, ma'am. Let me call my dear friend Avani to invite the resource person of the day. Avani, over to you.
Thank you, Ruhi. It's my privilege to invite our resource person of the day, Dr. Judy, the Associate Professor, Department of Computer Applications, Cochin University of Science and Technology. She has 18 years career in teaching and research experience. She has specialized in big data analytics, data mining, evolutionary computation, and computational biology. Dr. Judy has qualified Master of Computer Applications, MPhil, and PhD in computer science. Her paper were published in international journals, national journals, international conferences, national conferences, and were published as chapters in international books, series, and digital libraries. She has received Best Paper Award in CIT Biotech, Longest Continuous SBC Award from Computer Society of India, Significant Contribution under Computer Society of India Service. She was also invited as convener and resource person for national workshops, conferences, seminars, session chairs in national and international conferences. Now, I would like to invite the resource person of the day, Dr. Judy, to handle the session. Over to you, ma'am.
Thank you so much. Thank you, Dr. Lalita, ma'am, principal, and Dr. Anita ma'am for giving me this opportunity to talk on this topic, accelerating AI with GPUs. I thank you, Avani and Ruhi, for the introduction that you have given and for welcoming me. Okay. We'll just start the session. This is before we go into the session. This is what course are you doing? Your students from undergraduate course?
Yes, ma'am.
So you're doing a BCA?
Yes, ma'am.
Yes, ma'am.
Okay. So it's only BCA students are here? All year, final year, second year, first year?
Second years and final years.
Okay. You have had papers on AI, machine learning, data science, something like that?
No, they don't have artificial intelligence. Yeah.
Okay. Okay. So I just prepared it in such a way that we will talk about what AI is, as all of you know, and then AI is becoming so famous and so potential nowadays because of certain technologies that are assisting it. Okay, so and in that, one of the main technologies is GPU technology. So we'll be focusing on that a little bit, and then we can discuss if you have anything. You can feel free, though it is just an online session. I don't want to make it so formal. I understand that it is being streamed online and all that. Apart from all that, I request the students to discuss with me and let us take it as in a casual way. That's nothing wrong in that. So if you have any queries in between, you can very well ask me also, or you can wait up till the session is over, then we can discuss also. Okay. So that is it. I'll just share my video.
Yeah, ma'am.
The presentation. Okay. Is it visible?
Yeah, perfect.
So it is just a 1 hour talk, and I thought I'll just orient it this way. Okay, so I just, as you all know, just look into what is AI, impact of AI, on various industries. Then there is some concept which is called as AI accelerators. And then among AI accelerators, there are different technologies, but we are just focusing on what is the importance of GPUs and how it has impact on machine learning or deep learning. As deep learning is an emerging field in the machine learning. Then there is, we call it as like GPU accelerated computing. So what is this GPU computing means and how it works, and what is the overall ecosystem? Suppose you want to start programming with GPUs, then what are the other things that you need, like the supporting libraries, things like that. And then what are the recent GPUs that are in market right now? And just have given a case of one latest framework by NVIDIA, which is called as Rapids, which provides an end-to-end solution with GPU for all AI applications, especially including deep learning, using deep learning. So this is how I have given it. And I'm just giving only an overview of how exactly all these things work. If you want me to explain more on this, you can ask me also. Okay. So I think I usually ask the students for all this. I don't know, whether all of you know what is AI. Maybe we can have a 2 minutes interaction section also before going in and reading this definition. Anybody interested in saying what is an AI? Ma'am has, in the introduction, she has clearly explained that also, what is AI. Okay, tell me somewhere you find intelligence around us. Any idea? Anything you want to interact, or I'll continue? As a student, what do you think is artificial intelligence? Anyway, the term has artificial and intelligence.
Ruhi, you can respond.
Ma'am, I don't know much about artificial intelligence, but
No,
related
to be cool, okay? Just like that, I'm asking you, what do you mean by this artificial intelligence?
I think it's related to our computer and intelligence. If we input something and we will be getting our exact output, maybe that.
Yeah, see, it's simple as already given. You are trying to bring in intelligence for the system. Okay, you're trying to make a computer or any system intelligent. So why it is called artificial intelligence is because naturally it doesn't have intelligence. So we have to write some algorithms. And then make it an artificial. You have to give intelligence to it. So it is called as artificial intelligence. Okay, so like you can see many applications of AI you have seen around. Say you have a bot, robot, maybe an expert system, a recommender system. So even if you look into your YouTube, it is recommending some videos for you personally. Suppose you log in, you have some recommendations. Another person logs in, they have another recommendation. So that is also some kind of intelligence. Similarly, you have a lot of smart this driverless cars in the field of healthcare. Everywhere, whenever you try to make the system intelligent, that is actually called as artificial intelligence. So what is required for that? Looking at the definition, it goes like this. And as you all know, John McCarthy, he has came up with the term artificial intelligence, and he's called as a father of that. He has coined the term in 1955. Okay, so if you look at the definition, it's a field of computer science that is associated with the concept of machines which will think like humans and will behave like humans. At least they assist humans in a humanly way. So that is what is expected out of an AI system. Okay, so I'll just give you some videos which I've downloaded from YouTube. With full courtesy to YouTube, I've given the reference at the end of the session from where I've taken this YouTube video also. Have you heard about this driverless car?
Yes, ma'am.
Okay, have you seen a driverless car in at least in a video somewhere?
In some advertisement.
Okay, we can just go through this 2 minutes. I've just muted the audio. You can just look into it. You can think about what are the algorithms that they are using. What are the computational tasks associated with this? You can see, other than the physical driving of the car.
Judy ma'am, we can't see the video because it is shared with your slides.
Okay. 1 second. Earlier when we tried, it was working, isn't it, ma'am?
Yeah, ma'am, if you could share your entire screen, I think that will work.
Okay.
Stop sharing and
Now
it's seen.
it's in?
Yeah.
Okay. This is a YouTube video which shows how a driverless car works. You can look at the different aspects, computational aspects involved around this. What are the functionalities that it is processing? Okay, so you have seen that now. Now you can see the presentation, right?
Yes, ma'am.
Okay, so can you tell me what are the tasks that you could identify from there? What the car was doing on its own for the students? Just name few. Apart from that, it was driving. Other than that, what can you say something about the car that you could see as a in the computational side? Okay, you saw the car applying brakes sometime when the signal was there. It could read some boards. Okay, say if you're, it was reading some direction boards. Then what else it did? It could control the internal aspects of the car, like controlling the AC according to the passenger who's there in the car. So that you can see, it is like a different task, like it is reading some text and analyzing what to do, like NLP kind of, or text processing. Then it was doing image processing. You can call it as computer vision tasks. Okay, so it has got a lot of sensors attached to it. So at the same time, all these sensors work together. It has a GPS connected to it, and then all together, this takes a decision there. So this is an example of real-time analytics. As and when the car keeps moving, the data is being streamed, and some from all the information.
Hello. Hello, Judy,
See, it
ma'am.
has,
Yeah,
yes.
we can't hear you. I think it got audio was breaking.
It is not audible.
Yeah, now it's okay.
Okay, you are now. It's okay.
Yeah, it's okay.
Okay, okay. So see what we could infer from the car was that it has got n number of sensors attached to it.
Please
Okay,
check
and
slides also, ma'am. Slides. Yeah, fine.
so we could see computational vision tasks, we could see image processing task, NLP task, text processing, all those things together, which was actually performing a real-time processing. So driverless car is an example where you can see streaming data is being processed. So, and you must understand that any decision that the car or it has to take has to be done on a fraction of a second. So for this, you need to have advanced algorithms. You need it to be connected to advanced hardware technologies where you must have a proper bandwidth. You should not have latency, and that is what is very important in any AI related applications. Okay, so I will later share the other link which I have now. It has got n number of examples. It is an video which I have taken from YouTube, but I will, since we are getting lagged in time, I'll just proceed with what I have to say. I will share it to ma'am. You can take it and see. It is how the world will be in 2050. So it's a very fascinating video for the students. You will understand how much AI would be a part of us in our day-to-day life, in all fields of life. So that is the second video which I wanted to share. I can share it offline, okay, to your to ma'am. So now, as you all said, as we were saying, this is there from 1955. I said 1950s, and then step by step, this transformation took place. Earlier we had only basic. You have heard about this AI deep. What to say? It is winning over chess champions and all that game playing. We had robots which went to Mars. You have a lot of Pathfinder robots which was there in Mars. So many things has happened earlier also. So like in 1950s, you can see 80s, it was very expensive computing. You could see that if you have a supercomputer, then it will be occupying entire infrastructure in the building. Then in 2000s, you had CPUs coming up, and slowly, this transformation has taken place. And now, if you can see that people are talking more about AI, and you can see, as we said, as we have seen this driverless car, a lot of transformations has taken place recently. So why it is like this, and what is the reason behind this? That is what we have to actually look into. And you know that the impact of AI is on various industries. As if I can ask you in healthcare, for example, what do you think is the most innovative thing or fascinating application of AI in healthcare? You can tell me robotic surgery is there, that the robots are performing surgeries. Just imagine, because they are assisting the doctors, but in fact they are performing surgeries. Then you have a lot of medical data that is coming in and various medical assistive decisions that are being taken. Then in education, it is there. In social media, it is an example of AI being worked out. In tourism, business, everywhere you can see that there is an impact of AI. So there are a lot of companies that are working with AI. I have just listed down few from the some survey that was there. Like you have Google, Facebook, Baidu, Microsoft, Apple, Amazon, NVIDIA, all are with working on AI. Even if you're going to you're going to have a startup and you're going to develop some products, whether it is a web-based application or it is going to be an embedded system project or whatever, even if you're going to start, have a startup, people want every product that you develop to be smart. So smart means making it intelligent. So intelligent means, again, it is an AI component somewhere. So it is not only that the bigger companies and the business is moving towards the AI race, it is even a small company or a small application that you build, even a project that you do, we expect that there should be some kind of intelligence built into it. That is a scenario right now. So I think as a student, I thought I just wanted to tell you this because I was asking you what is AI. People will, you keep hearing all these terms and you may be a little confused with what these terms are. You have AI, some people say machine learning, some people say deep learning, then they say data science, then even another thing is data mining. Okay, so these are all terms and sometimes you can see the applications of AI is so much prominent that people talk about NLP, robotic speech processing, autonomous vehicles, speech to text, so many things are coming up. So you must clearly know what all these things are. Okay, so AI, as you all know, it is a broader term or an umbrella term, where, as we earlier discussed, it is just bringing in intelligence. It's a complex system. If you say I'm building AI system, so it has got all these algorithms there, hardware components there. All this together is an AI. So basically, if you are making a system intelligent, by some means, it is called as artificial intelligence. There are a lot of interdisciplinary fields that are associated with AI. Okay, so you can see any component or a machine which is exhibiting intelligence. Okay, so you're trying to simulate some kind of an human intelligence also. So if you want the system to actually be intelligent, you have to instruct the system to be intelligent. You have to train the system to be intelligent. Systems are just, hardware components. So you need a set of algorithms that can help your system or make the machine learn. Okay, you call it as a machine or a system. You need certain algorithms to make the system learn. When you write a small program, if you want your system to play chess, if you want to, for example, you as a student, you are writing a lot of programs. So if you want your system to perform the operations of a calculator, what do you basically do? You write the code. So this code or the logic that you apply, when you execute it, the system performs the task that you have written. Similarly, if I say that the system has to be intelligent, you have to design a robot and it has to say it has to cook for me, then we have to bring in intelligence to it. And for that, you need to write code, you need to write algorithms, logic. So that is actually called as machine learning algorithms. So that when you talk about machine learning algorithms, there are many classifications for machine learning algorithms based on the type of task it is performing, type of learning that it is. Okay, then there are, you can go deeper into it, like whether it is supervised, unsupervised, parametric, non-parametric, and there are a lot of classifications. So you can go deeper into that. So for a machine to be intelligent, you need machine learning algorithms. Then comes deep learning, which is very prominent nowadays. This machine learning is a broader term, and there are different types of machine learning algorithms. As I said, based on the characteristics of algorithms, there is a bigger classification of algorithms which were developed, and they are called as soft computing techniques. Soft computing techniques were algorithms that were developed looking at the human bio-inspired computing, you can call, or looking at the nature-inspired computing. Like there were a class of techniques like genetic algorithms, swarm optimization, swarm intelligence. We had fuzzy logic, which mimics the behavior of how humans think and behave. You had neural networks. So they were all models that are developed, and they come under soft computing techniques. So because see, as we say, nature is the most intelligent, intelligent concept that we can develop ideas from, and human behavior, humans are more intelligent. We were trying to simulate the behavior, or we were trying to model computationally how these human intelligence works or nature works. Even You have heard about this ant colony optimization, particle swarm, so many things. So those set of algorithms are called as soft computing algorithms. In that, neural network was one algorithm which was just mimicking the structure of brain, the neurons connected in the brain. So that from neural networks, it came the concept of deep learning. In fact, if you look at the brain of humans, we have around 10 power 12 neurons interconnected together. Am I audible?
Yes, ma'am.
Okay, so you can stop because I'm just telling you how things are structured. So that these neurons in the brain are connected, interconnected together. And as a human being, we take all decisions with common sense, real time. All these features, what we expect is there for a human brain. So that is where neural networks came in. And in fact, it has n number. So that there are technically, if you look at it, if you look into the algorithms on a later stage, there were problems with neural networks when it could not accommodate more number of layers into learning. You had vanishing gradient descent problem, and hence they have come up with another types of learning that, which could be applied for neural networks and other models also, that is called as deep learning. So this deep learning has proved itself to be so good that it has become another area of machine learning. Sometimes people in the newer generations tend to say that they call deep learning as machine learning kind of, but there are a lot of other parameters and other machine learning techniques which are useful, which can be used for problems also. Deep learning is not the panacea for all the machine learning tasks that is to be performed. But if you see, as I was showing you, the self-driving cars, the speech recognition, robotics, emotional processing, so many things apply deep learning algorithms. Now people talk about data science. So as we said, data itself, like you had BSc computer science, there are courses that are started in IITs, IIScs, CUSAT, in your universities, everywhere that there is a course which has been coming recently, like 4-5 years. You have an MTech in data science, a BCA, BSc data science, kind of, because data is the new oil, as you all know. In fact, knowledge is to be given to a system. This data is the basic way in which you can embed knowledge into a system to make a system intelligent. Data has got a lot of properties, and data, as I used to say, we have a lot of data around, and we need some techniques to infer some information from this data. That is called as, so this science which talks about the distribution of data, types of data, different pipelines of data acquisition to data visualization, okay, and then the properties of data. This is actually called as a data science. So it's and as you all know, newer terms have come in, which is called as big data. So big data means it's a data which has got various characteristics. So in fact, it is written there, big data. I'll just give you, I want to tell you, because many students think that big data means it's large volume of data. It is not large volume of data. It is it's a different category of data. See, a data can be called as big data if it is having minimum few characteristics, like it should have volume, or it should have velocity, it should have veracity. Okay, so value, so many V's are added to this data. So like, for example, social media data that we are talking about is an example of big data. I used to give this in all the classes when I take. I want the students to understand. Say, suppose I have taken this session, and at the end of this session, I am asking you to give a discuss about my class. Okay, so I'm creating a small group of this 45 participants here, and I'm telling you, kindly discuss about my class in WhatsApp. And imagine that I am getting access to all the text that you people are sharing. Okay, so for me, my intention is after this, I want to get the data that you people are, I have access to it. Okay, so, and I want to know, my task is to know whether I had a positive feedback or a negative feedback. Just imagine this situation. It's a very simple situation. For a student, I just want you to think, can you tell me if I have access to this social media data, so 45 across 45 communications, okay, how do I store this data? What format will I be able to store? Because I want to analyze it. So either as a human being, I can go through the each communication that you people, each chat that you have been sending to each other, okay, and then I will try to assess something. If I want the same thing, if I want the system to do, that is social media, social network and social media, that data mining, if I want to do, I want to know whether it is a positive polarity. What is the polarity, positive or negative? Okay, it's called a sentiment and analysis. It was a good one or a bad one. Or I want to know Simple. I just want to know it's a positive feedback or negative feedback. Think right from the data acquisition to the visualization. What you will apply. First of all, if I tell you, what will be the type of data that you people are sending across? Okay, so how will I save that data? Suppose I have access, I told I have access to this data. What will be the file format in which I'll be saving this data? You want to give a try, anybody? How can I save this data? That is a chat that you people have been sending. I have access to it, so I want to save it for analysis. How will I save? What file format? Any idea? Just give a try. Like a text file, you can say. Okay, what will be the type of data that you people send across in chat? Because I can only see the screen, what you people can, I can't see you all. So in between you can say some answers, I think. Are you able to understand what I'm talking? Okay, am I online?
Yeah, ma'am, you are online.
Yes, ma'am.
Okay. Just tell me, what will be the type of data?
Girls, you can post your answers in the chat box also.
Yeah, you can understand the complexity, what I'm trying to say. See, you will not be typing the talk that she gave for 1 hour was very, very boring, or it was very excellent. And it was, you maybe, what else you will be sending there? Emojis? Some trolls maybe? Some text? This text also, will it be in proper English? Yes or no, you can say. Will it be proper English that you will type like this? In fact,
any format, ma'am.
It'll be any format, like an image, or it could be it could be a TIFF GIF file, whatever you call. And in fact, as a human, if I'm getting access to this 1 hour chat of this 45 participants, I don't think applying my human intelligence, whether I will be infer something, I really don't know. Okay, we expect a system, the main medium of communication is social media nowadays. And if I'm going to launch a product, or if I'm going to do something which is very important for me, like a company has a product, it has to be launched, and I want to get access to this feedback of how the product has reached the audience. So this is a real-time problem that we have now. As a human, I have a difficulty in inferring the message that you have. It is not because that you have typed when I say the different types of data, it doesn't mean that it is integer, float, text and all. It is structured, unstructured, semi-structured data. The data that you send itself is not in a structured form. Means I am not able to hand it and store it into a CSV file, or an RDBMS, or an SQL, or a JSON object, or an XML object. It is difficult for me because I really don't know what type of data is being generated out of all these things. I don't have a common data structure to handle all these information there. Then next thing is, once I have this data, I have to work on it. I have to kind of do a lot of pre-processing to filter out the noises, because all this information then may not be directly pertaining to the sentiments that you're trying to say. So there should be some value, there should be some veracity. That is how I have to, the data should be authentic. So that is another V attached to it. And the speed in which the data is being collected. Then imagine the situation of a driverless car. In a fraction of a second, how much data it is processing and how it is taking a decision. So that is the challenge that we are facing nowadays. So this data is social media data is an example of big data. That is why this big data boom is there. Because if you want to handle this type of data, as I said, my intention is to know the feedback. I have the data with me. I mean, there is a saying very famous going around nowadays. We are drowning in this data. Even I am drowning in this data, but I am starving for one piece of information. The vital information that I want, I'm starving, because I need to have that kind of algorithms which can look into this data. I need to have that kind of memory capacity to store this data. I need to have that kind of an infrastructure to store this data, whether on-premise or cloud, or you have some storage solutions at your place. So that is necessary. Then you need to have algorithms that can parallelly or distributedly process this and get back the information in a fraction of a second. I need to have, the typical machine learning, I'll say, for example, you have different parallel models that have come up, like the MapReduce programming, or you have this HDFS file distribution systems, which are distributed file systems, like Hadoop distributed file systems you have, or you have this GPUs which are coming in, which can process multiple streams of data. Similarly, technologies are helping us to process this data, and this big data is also another field which is coming in. So you can just look into it. It's all connected together. Okay, we don't have to, and this entire processing process of this is called as data mining. Collecting the data, integrating the data, then looking at pre-processing, filtering, removing noises, and then converging this data, integrating this data. Basically, data integration is very important, because all this should be for taking us unanimously. They should take a single decision. So that is important. Then applying the algorithms, then visualizing the results. So the whole process, we can call it as a data mining process. So now this I already told you. Deep learning has there are such an efficient set of algorithms that people you can hear deep learning a lot, because it has got many benefits. This is a it is very robust. It has got it is generalizable and it's scalable. So as it is a technique to handle big data also, even though there are other learning techniques which are there to handle different characteristics of big data. Like for example, you have I told you velocity is a problem of big data. So if you have to have you have online learning algorithms. It's called as interactive online algorithms for handling the velocity problem. Similarly, deep learning is very good in handling the volume as well as the variety concept of big data. Okay, so and along with this AI accelerators, deep learning is becoming very efficient nowadays. So I want you to know what is this term, which is called as AI accelerator. So as I said, some components, high performance parallel computation machines are developed, okay, and they are specifically designed for handling this AI workloads. So which we were talking about right now, some examples which I said, like driverless car or robots and all that. So for that, you have AI accelerators. There are you can see different HPC way of handling it. You have CPUs connected together. You have GPUs, okay, and I have given the properties there. You can see that like they are vector-based SIMD with the DL extensions. We'll go into that. Then you have this field programmable gate arrays, that is FPGAs. That is another technology that has come in. And then you have another accelerator, which is called as ASIC, application-specific integrated circuits. Okay, so this is just an example. Like if you have CPU and GPUs, you will understand that GPU has hundreds of cores when you compare it with multiple cores. The architecture of GPU itself is designed in such a way that it can handle multiple streams of data. So if you look at CPU, they are designed to handle this, as we all know, it can handle wide range of tasks. Okay, and you have a CPU clock speed, which is it is measured by the CPU clock speed. So you will say how much, what is the performance, teraflops, similarly. But the problem is concurrency is a little problem when you talk about this CPUs. Whereas GPU technology has overcome this, and GPU is designed to quickly, you can render high resolution images and video concurrently. That was where it was basically designed for. But since it can handle this multiple sets of data, okay, they are used for non-graphical tasks also recently. So that is the breakthrough here. They can perform parallel operations on multiple sets of data. That is how the architecture works for. Okay, and that is why nowadays, even for non-graphical tasks, okay, like non-graphical task, I mean like the machine learning task or scientific computations, also GPUs can be used. So that is what is the advantage of GPU. And when you talk about this FPGA, it is an integrated circuit made to be it is field programmable. You can actually reprogram it for different applications. So that is another accelerator. Then you have application specific integrated circuits. Okay, so this is for one specific application, you will be actually embedding it, and then you will be developing some kind of IC. So that are also faster. Earlier it was there for biometric applications. Now you can see it for other applications also. Then comes the GPU. So I think this is just we have taken from the net. I think it's a NVIDIA 1080 card, GTX card. There are a lot of newer cards that are coming in. We'll discuss on that. So this is how it looks like. And then it can be, we say that it is important for deep learning because parallel as deep learning works on a large number of data, you will have parallel matrix operations on it, and then for that GPUs are really the best options. Okay, GPU also comes in two ways. One is integrated graphics, that is GPUs will be built inside a processor, and usually you can see that in your even I think most of you will have a laptop, and if you just go in and check, you will have a GPU card there with some integrated GPU units there. That is mostly used for gaming and 3D animation. But other than that, you have GPUs which are coming in, which are dedicated recently, dedicated graphics processing unit that is found inside a graphics card for desktops also, or in even in high-end laptops. So this is having, see, this comes as a system as such whole. So we'll see how it is. So some confusion sometimes happens whether you have a graphics card and GPU, are they same? So they are, see, GPU is the actual chip that you use it, and this GPU is installed inside the graphics card. So this is just an example. As I told you, this NVIDIA is one company which is producing a lot of GPU cards. So this is how it looks like, a GPU card of NVIDIA GTX 1050 Ti, not the recent one, it's a little earlier one. Another GPU card by AMD. So, you know, companies like Intel, AMD, NVIDIA, so many companies are there. As a student, you may be knowing about the companies that provide systems for you. You have a lot of companies that gives you high performance computing systems. So this is another card by AMD. It's called as Radeon Pro. So as of now, I think so when you can browse in the net, you can see that biggest manufacturers for graphics chips are AMD, NVIDIA. Yes. Okay, so I told you this. Why do you want to include this for a deep learning? Because you want the bandwidth needed to see, you need large data sets, large number of operations that are performed on even a simple computer vision tasks. So for that, you need the memory bandwidth to be higher, and then scalability should be there. You need to even connect GPU to GPU, which can perform which can massively process data parallelly. So that is the advantage of using this for, I have just mentioned it like GPUs for deep learning, but it's like GPUs for AI tasks. All the AI tasks has this property. And optimization is another important thing. You need to perform a lot of optimization techniques on the algorithms that you develop. So that will be better on a GPU. So this is one simple architectural difference. You all know how a CPU works. You have a control cache and DRAM with arithmetic logic units. If you look at GPUs, it's going to stream multiple data. It is a streaming, it has a DRAM and it has got multiple streams attached to it. So we'll see in detail how it is. And when I'm talking about this parallelism like that, there are different types of parallelism. Okay, so this is some basic technique about, you know, this is how a different parallel system works. Okay, types of parallelism that you can bring into a computing system. So what you have a single instruction, SISD is one model you can see on the right side. You have your processing unit, you have single instruction and single data. That is the SISD simple model. But when you look at other models, you have single instruction, but you will have multiple data here. And the other one is multiple instruction and multiple data, and multiple instruction is single data. Means you will have a single data, but multiple instructions will be processing. So based on this, actually, your algorithms also change. How you have different programming frameworks that can accommodate these kind of, so if it's a distributed system like a MapReduce, it has got its own way of, so you see, actually, this is the architectural wise difference, and you will have a programming paradigm which can accommodate these types of parallelism in your when you're writing your tasks, when you're coding your tasks. This is what we said. It's a serial non-parallel computer. Simple. What we have, you have just single instructions, and then you have the processor processing a single data on it. When it comes to type of parallel computer, this is what I said. You have single instructions on multiple data. Okay, so there will be a data pool, and you have this single instructions which can be working on this multiple data. So GPUs actually has this process. You can stream the data, and on this multiple data, a single instruction. So parallelly, this can. So if you have a matrix operation, you have tensors or a data structures that can actually split your process into smaller units. Okay, simple. So it will be like a multiple instance of data, and the same operations can be performed on this multiple instances of multiple blocks of data. So that is what is followed in a GPU. And other technologies which are there is multiple instruction, multiple instruction, single data, and multiple instruction, multiple data. So this is what. So this you can just note it down. If people ask, you should know, like CPUs are multi-core processors and they have MIMD architecture, whereas GPUs are SIMD architecture. Hello.
Yeah, ma'am, we can hear you, ma'am.
Okay. So this difference makes GPUs well suited for deep learning process. Okay, so still see there are differences. Even GPUs can be used for number crunching, numerical problems also, where we can use it for high performance computing systems also. Sometimes it depends. You can also use GPU specifically for AI related workloads. So it depends on the what floating point operations that you use, whether you have half precision, double precision. So based on that, the performance of GPUs also change basically. So if it is an AI related, what you have to apply that. You have to decide what task that you are going to use these GPUs for. Okay, so that is also important when we are talking about the different types of tasks that you assign to a GPU. So this is the architecture. Once again, it is just explained to you. You can just go through. So this is the basic architecture of a GPU. As we said, the components that comes in with a GPU, it has this DMA engines, direct memory access engines. Then global GPU memory will be there. You look at the disk, they say like a NVIDIA A100 card with 40 GB memory. Like that, it has got its own memory attached to it. So that is the advantage of this GPU cards. Okay, you have L2 cache and you have multiple streaming processors. These are the vital components that make up a GPU hardware. So different, when GPU to GPU connections, there are even later technologies that are coming in. Sometimes, as they have shown here, it is connected by from the external network by a PCIe connection. Or sometimes you have latest technologies like NVIDIA gives, like you have NVLink, which actually has higher speed in the data transfer between GPU to GPUs also. So that this I have told you. So this multiprocessor, as you know, this streaming multiprocessors, they have the whole task schedulers, computing units. They have the in-memory chip, several different caches, everything. And then you have other DMA engines, LQ cache, load, store, and all that. When we are talking about this GPU accelerated computing, sometimes, as I told you, you can see that there is a combination of CPU plus GPU. So if you're going for a server, like an AI server with GPU cards, so this GPU cards will be populated along with a CPU server. Okay, so which has to have access to the environment. I will show you the ecosystem wherein the GPU to GPU communication will be separate, and then this will be taken care by a CPU server. So even here in our department, we have recently got a fund from state government, and we have set up an AI server. We had one Hadoop cluster, which is totally a distributed system with Hadoop distributed file system. Along with it, we have got one AI server. So we have purchased two A100 cards from NVIDIA, and we have a AMD processor, a server, which is also which is connected to the two A100 cards that we have. So traditional CPUs, if you see, they are not economically feasible. When we are talking, we know how, as I explained to you earlier, because of it cannot handle this parallelism in that way. Whereas if you are going for a CPU with some GPU accelerator, it will be easy for us to execute that high-end AI tasks at our side. So that is this. That is how this combination works, and that is how GPUs are good for performing AI tasks. Okay, so how, as I said, time to do a task, the latency is very less, and number of tasks per unit time is throughput, that also is very less. So here we have just shown there, for latency is like 10 nanosecond per task. Okay, so whereas for a CPU, it will be like 1 nanosecond per task, because you can see the number of cores that are there for a CPU. For a Core i7 system is like you have 6 cores only, as you all know. It's 13960X Extreme Edition. And if you take a normal Titan GTX card GeoForce, it has got 2688 CUDA cores associated with it. So CPUs are latency optimized, but GPUs are throughput optimized. So you can understand what is the efficiency of a GPU which are with it. Actually, this is a GTX card. You can look at we will just go through the other versions of latest GPU cards that are there, which has got more cores that are associated with it. So this is how you go for a GPU acceleration. Okay, so compute intensive portions, we give the GPU can take care, like providing a supercomputing level of parallelism. Sequential parts can be still performed by the central processor. So so many solutions are there for this accelerated computing. So at the PC level, we have these cards read on by AMD cards or NVIDIA cards, which you can have it with your PCs, or sometimes they provide solutions as a workstations. Like you have so many other companies also, they provide a card with the entire system, like a entire workstation solution with the GPU cards embedded in it. Or sometimes a data center kind of, as I said, you can have AI servers with lot of cards populated together. That also, it can be populated in such a way that they can handle AI tasks as well as HPC tasks. Okay, and sometimes you can have environments like you can purchase on cloud facilities are available. So you don't have to really purchase a GPU or set up a workstation, or you don't have to populate it our end. You can go for a cloud-based solutions to work on this GPU. So if you have a task, say you have got a project as a student, and then you want to use this GPUs, you really don't know exactly how much workload you will have, what will be your training data set, and then what is the size, what is the algorithm that you're using. You can maybe purchase a cloud-based solution, because as and when you need, you can work on it, and they provision you with the number of GPU instances. And then after your project is over, you can just maybe you can stop the utilization. So that process, that way also you can deploy this GPU solution. So either as a desktop PCs or laptops, or you can have workstations which are desktop or even mobile workstations where you have good mobile like laptops with good GPU cards, or a data center solutions, or on a cloud-based solution you can go in for. Okay, and I told you there are many manufacturers, and NVIDIA is having AMDs are also competing, but I think NVIDIA is on the top as of now. So this I have given you some models of AMD GPUs and NVIDIA GPUs. So NVIDIA, one thing I want to tell you now, we are talking about the hardware concept of it. Okay, but this NVIDIA GPUs, I've just added 2 or 3 slides, like they are coming up with some, which we were talking about, workstations. So those DGX workstations are there, where they are connecting this 8 or 16 A100 cards together with the technology that they have, which is called as an NVLink technology for the interconnectivity, and then so on. But one thing you must understand, I'll skip this. This GPU computing is important. See, earlier, as we said, programming was a difficult task. If you want to write codes for parallel processing, I think the teachers will know, it was very difficult to do the programming part. Later, what happened, there was a revolution in this. Okay, then came this CUDA programming had come into picture. And with the CUDA framework, we are actually able to program GPUs faster. So once this NVIDIA introduced this CUDA, now what happens is they have a lot of frameworks which will support programming, CUDA programming. Actually, it is you have a lot of interfaces, APIs, which are on an abstract level, on a higher level, where a programmer really need not bother much about the hardware or how it is actually, how to write code on a hardware level. So it's all a lot of libraries that have come in. As you know, this PyTorch is there, the TensorFlow. These things are helping us to actually code easily without having any hardware dependency. So that is the breakthrough in GPU computing. So, and if you look at the computing environment or ecosystem, You can see this in 2000s that was there. Now in 2010, what we are using is all this NVIDIA CUDA. I think you people, those you would have heard about this TensorFlows, PyTorch and all. So these are environments where programming paradigms where you can, it is useful for you to actually directly code GPUs or write codes that can execute on GPUs. And this is how the entire system will look like. You will have the hardware part either as a workstation or a cloud or server. Then you will have the libraries in between. Okay, so this gives us the the user will be only interfacing with the libraries, CUDA, XAI and all. They have different libraries for graphs, ML, DL, train, inference and all. And then you have a lot of frameworks which will help you to access this APIs or libraries. So this is the programming for a programmer. They can just deploy this either on a cloud deployment or ML services. So many tools are available. You can see MXNet, PyTorch, TensorFlow. So you can make use of this frameworks and you can easily program your GPUs, machine learning tasks or any task that can work on GPUs. So this is other components for the GPU computing. You can see you must know what are the different languages. And so there is no one end-to-end solution. It depends on your task and project that you are doing or the task that you're doing. Whether you are trying to crunch some bioinformatics projects, like you have a sequence data and then you're working on it, or if you have computer vision tasks, or you are building a robo with reinforcement learning type of things, or you're doing video processing, what is the task that you want to perform? Based on that, you have to choose a set of verticals from here. So what language you want, what APIs you want, what are the debugging tools? Okay, so like what acceleration, what type of combination you want to give, whether you want to go for workstations, you want only GPU to GPU computing, or you want some part of your applications is double precision or single precision. What is the type of task that you're going to do? Based on that, you have to choose the set of libraries that supports it, the type of hardware that supports it, the type of frameworks that support it, and then you have to move ahead. So these are the different things that are available, but we have to choose based on that. As I told you, PyCUDA, OpenCL, or whatever it is the programming language. Like we are explaining each component there one by one. You can just see this is what is available. So you have to decide what you want to take. So CUDA libraries, as I told you, based on the task, like if it is a mathematical libraries are available, parallel algorithms are there, video libraries, or you have so many libraries for different tasks. And we have this entire, if you are going for a entire solution, then you will need a full management system. Like if it's a cluster or a server based, you will need an interface to entirely manage the cluster or the server. So for that, there are different solutions that are coming in. As we said, we have Xclarity here as the interface tools for managing the server that we have. Or as I said, in a distributed system, maybe we have this Cloudera, Hortonworks and all for a Hadoop distributed file systems where GPUs can be integrated into it, but they are CPU-based systems that we have built. So that also comes in. So if you are, you have to decide what kind of a profiling and debugging tool that you will need. So if it is as a solution, it is provided as a solution, then different clusters or management softwares are also coming in with it. Other than that, if it is a single GPU that you have a workstation with a single card, say you have a GTX or a RTX card, then we can directly use our libraries that, like for example, a Python framework is enough for you to directly code with the GPUs. So you can have this Python code like a Jupyter notebook or somewhere, and then you can start executing your program. So that way. Okay, this is what I said. So it depends on how you are going to do. There are a lot of, if you can see the software engineering side also, you have this ML ops coming in and DevOps are there. Okay, for that will assist in every step of AI and HPC software lifecycle. So that is a breakthrough in the field of software engineering. So from DevOps to going even to ML ops. So you have a lot of containerization coming in. So these NVIDIA, for example, they have this NGC, they have containers. Then so that kind of a difference is there in the software development lifecycle also. They provide lot of solutions are readily available wherein you can integrate into your task that you are performing. Okay, this is one example of to just tell you with all this, there is one Rapids, one framework. Okay, so there is one, I don't know if I'll try playing this video also. So this is Rapids is a framework which is given by NVIDIA, which uses this, which is good for GPU compute and parallelized data loading, data manipulation. The end-to-end framework is given there. So you can see that they will give you the training, testing. I mean, they have provision for extracting, transforming the data, training and testing data. Then, as I said, to build the model, and then you up to visualization. So this is the framework they give. So this is an end-to-end solution. It's a trademark. I have just mentioned it. There are other frameworks also available. I was just browsing through NVIDIA's recent development, and I found that this is one end-to-end solution that was there on the NVIDIA website. So I've just taken that, and they have just given an example of Walmart. I don't know if this video will play. 1 second. Okay, I don't want to play this because the link is given.
I take my health very seriously. You know me. So while we take great care of our own health, it's not cool.
Can you see the presentation right now?
Yeah, ma'am.
Okay.
Yeah, we can.
Yeah, you can just check into this NVIDIA and take and have a look at the different applications. So they have just given how this Rapids is a best suited framework. So there is a small video which talks about this Walmart. So they say that they have just given a very good, at least at the research level, it will be useful for you, because they say they customize their products every week. So they are actually kind of an integrated system. What they are doing is they are doing feature engineering, I think every Tuesday or Friday, some day that they are talking about. And then they collect inputs from this customers. And then they feature engineering, they are doing every week. And based on that, the features are changed and the product is completely redesigned. And then it comes out every week. So that's how they are actually applying the live or day-to-day intelligence into, or by getting a feedback from the users. So that's how they are using this technology for their production line. So that's an example of how it works, for how the business analytics works as of now with the help of this accelerated computing. So that's why I've just given that line. You may please go through that later when you have time. So these are the references, and if you have any queries, you can. So I was trying to just tell you what is AI, what are the different technologies or terms associated with AI, like data science, machine learning, and all. And then what are why AI is so successful nowadays is because of the algorithms and all, as well as the accelerators that are there. So one major component is the GPU. So we were talking about what is a GPU, what is the architectural difference between this GPU, CPU, what are the programming paradigms, what are the companies that are coming out with GPU cards, and how you can deploy a GPU at your workspace. Like it depends on the type of applications, and then some examples. So I think you can ask, is it okay or?
Thank you, ma'am. Now the session is open to queries. Those of you who are having any doubts, please post it in the comment box or unmute and speak.
Thank you so much, ma'am, for an elaborative session. Now it's open to the students. Girls, you may post your queries in the chat box. Also, please note, an attendance and feedback form will be shared after the Q&A session. Only those who are submitting the form will be receiving the e-certificate.
there is a question, will AI take over the world? Will it steal the job of people? No, nothing. According to me, there is nothing like AI will take over the world. See, AI will assist us and it will help us. As you know, every technology has got its good and bad. Okay, so we have to be careful with how we use the technologies. Even we say mobile phones is a mobile technologies. You know, there are a lot of positive things. When banking came up, people had this doubts. Internet banking is going to steal, close the banks, that is jobs. No. So when, see, it's a revolution, or you can call it as an evolution of technologies. Okay, so as and when new technologies come in, new job opportunities come in. See, as I told you, now people are talking about you are studying this course, you are going to take up data science course, new courses comes in, we will learn more about it, we will learn new technologies, and there will be a lot of job opportunities there. Data scientist job is, they say it is the most, some statistics earlier I used to say, data scientist, data analyst, these kind of jobs are coming up. They are going to be the job of the next century, they say. So it will not steal the job of people. You will have a different set of jobs. You can see, if you can take any sector, health or bank, you can see there are a lot of technologies that are come up now. So earlier also it was there, now also it is there. Only thing is the way in which we work has changed. Earlier you had all wired connections, now mobile technologies have come in. So new set of jobs have come in. Okay, so it is not going to steal the job of people. It is going to give, on a positive way, we can say it is going to give job for many people. So we have to keep updated with the technologies, and we should, and there will be a lot of job opportunities. Maybe the nature of job will differ, type of job will differ, but that has been happening from the beginning. Okay, in every sector there are advancements. So AI is always to assist human and not to take over human. Devika, I think I've answered your question.
Ma'am,
Yeah.
there is a question posted in the comment box by Fazmi Firoz. What are the cons of artificial intelligence?
Cons of AI, you mean to say that was the same question she was also posting? I can't say anything as a disadvantage of AI, the same way I was explaining there. Okay, I can only look into being a computer science person. I really don't want to mention any disadvantage or cons, as you say. Okay, because I have seen it helping human being in every aspect. And okay, because earlier when you remember, if I remember when I was studying around 20 years back, people used to say that it will make people lazy, that, this and all. But I really don't get any. Only thing is power consumption things. See, that is all taken care. That is what I want to tell you. When we are developing new technologies, they say even GPUs, it consume lot of, it dissipate lot of heat, power and all, they say. But see, there are immediately, we as humans, we will have a solution for everything. And I feel necessity is the mother of invention. So as and when we invent new technologies, okay, so we will, if at all any negative aspect is there, we will immediately find out a solution and then we make it positive. That's what I say. Other than that, I don't think there are disadvantages. Okay, if you look into the net, they will say it will make human idle. It's dissipating a lot of. Once as a student, like I want to tell you, get into this Google. They will. You can see how this. It is called as Google Plex. Have you seen that? In US, the Google office, have you visited? They will show you a virtual tour, and I will say, I'll just tell you how much how much technology they have implemented into the Google office. It's called as Google Plus, like a multiplex plus Google, I think. So if I'm right. Okay, just see how things are there. So even you can get into their data center solution, see, because many times people say that this global climate change, the heat it is producing, and like when we are going in for exascale, from exascale computing, there are a lot of debates on that, whether we should reach up to that level and all that. So as humans, what we do when we develop, so there is a necessity, we invent something, there may be some, as a byproduct of it, there may be some negatives, that what people do is immediately we come out with a solution to that. So that is how I feel. Otherwise, I can't, I'm not able to think about any cons of AI. How close are we to achieve AI? This is a very, very, what to say, it's not a quantitative question, but we are already around AI. Okay, we are living with systems that has got intelligence now, and it will keep improving. Okay, there is no end point to say that this is when we have achieved AI. Earlier, you remember there was something which is called as a Turing test. And he's called as the father of AI, Alan Turing. And when I exactly don't remember the year, but when a system was there, when can you call a machine as an intelligent system? I have not touched upon AI. That's why I have not gone into things like that. And it is a general technology session. That's why I was just talking about GPUs, but that's called as a Turing test. So I think you would have heard about this. It's a very simple test, and it's called as in 1950s. We said when it started, and he's the father of AI. What Turing test says is that suppose you have assume a situation like this. I am talking. I am just kept. I'm communicating to somebody, and there are two people sitting at the other end. Okay, one is a system, and other is a person. I ask something, I give a task or whatever task, and that I'm asking the other two people to do. One is a human being, one is a machine. I should not be able to understand which is a machine, which is a human being. I'm just putting it in a non-technical term. Okay. So if that system is passing this test, that I'm not able to identify whether it is a human or a system, then that system is said to be intelligent. That's how, if you can, exact definition, technically you can see that is called as a Turing test. Because Alan Turing is called as a father of AI. So he has given this text. That is still there. Okay, so if you look at that, they say that even it depends on the benchmarks that you set. So sometimes you can say no systems have actually cleared Turing test, but up to some extent, yes. So if I say the world chess champion is there, Gary Kasparov was there, that is the first time when a software, I think the software that they used is called as Fritz software, and the supercomputer was Deep Blue, I think. And that won over Gary Kasparov. So imagine, can I say that the system is not intelligent? So it is able to win over a world chess champion means the system is intelligent. So, but still, if you look at different aspects like many things like the common sense, see, it depends on how much efficient you make your machine learning algorithms, how much efficient you build the system, that the system keeps improving its intelligence. So that is my answer to it. So we are already in the era of AI from very long, and we still keep improving. And if you look at human being, they are a super natural creation of God. And acceleration, some hardware is also associated with the person, like you can check for some physiological parameters. Along with that, rather than a normal human being, an intelligent system will be able to assess what kind of emotions the other person is having. So a lot of breakthroughs are there in every field. There is, according to my knowledge, there is no benchmark to set saying that okay, we are already achieved AI kind of. It keeps growing, and always there will be some gaps also. Okay, so.
Ma'am, one more question is there.
Okay.
By Disha. How AI is implemented in virtual assistant technologies like Amazon, Alexa, and Google Assistant?
Okay, so we were talking about deep learning. You can, that is one technology that Alexa actually uses. Then it uses text synthesis, speech processing. Okay, so these are technologies that Alexa actually uses. So you have this dot smart speakers or Amazon Echo. So these are technologies that it is using. There are error rates also that they say. So main features you can say it is like speech recognition, then natural understanding, natural language processing, understanding its things like that. So they are the applications of AI which are used in Alexa or Dot. And I think you can also look into it because Alexa uses other advanced algorithms where self-learning technologies are also used. Because it keeps updating its so this you can go through the Walmart example also, which I've said, because nowadays the machine learning models are built that we built are should be used for real-time processing or stream processing. It is not going to be a typical model which is, see, it has to incorporate newer models on the go, as I said, online learning kind of. So that is also some machine learning techniques that are they are using there when we're talking about AI. So basically NLP, speech processing, these are the things that Alexa, that they uses. Anything else?
One more question by Ragendu. What skills do I need to get a job in AI?
Okay, skills. Okay, so you have to have good knowledge in, as we were discussing about, so or AI concepts, all this comes in types of learning, knowledge representations, then types of algorithms, things like that. You must have a good programming tool for building your algorithms that you have learned, like the Python. Okay, so and then you must then see, that is the first thing, that is the foundation. You must basically know how a AI system works. For that you should learn the machine. When I say machine learning, again the mathematical foundations of that and things like that. Plus you should after that you should know, maybe if you are interested on a particular area of AI like an NLP or vision processing or speech, you can even move further into the different class of algorithms that are applicable for or the data. Because when you are taking up a particular domain, after the basics, when you're thorough with the general machine learning algorithms and all, you can even, if you have a specialization in mind, like you want to know how this Alexa works, or you want to know how this robots work, then you can take a study further on that. So if you're going for like a robotic surgery, you are interested how robots work, you should learn the hardware of how a robot is built. Okay, how embedded programming works, how reinforcement learning works, what type of learning, especially machine learning, if you're talking about, if it's an intelligent agent that you're looking at, like a robot or any bot, the class of algorithms that are mostly used in game playing or any bot is usually reinforcement learning. So you will have to learn more on that. You must learn, if you have a domain, you should understand how this medical data is used, or image or speech. Okay, how NLPs work, like that. Also, that will be the second level of thing that you should do. For everything, as a student, I feel you must start programming also. You must learn the libraries that are there, and you should be able to understand how to bring in parallelism to the code that you are bringing in. I mean, you are typing. So that will be the three ways in which you can do. Learn the basics, learn the general algorithms, learn about data, AI, knowledge representations, machine learning, all those things. Then focus on a specific area. Also look at the programming frameworks that are available. Stick on to one as a student, then develop yourself. So that if they're asking you, if there is a problem at hand, saying that you will be able to identify what type of an AI task that is, what algorithm you can apply, what frameworks you can use, how your data is going to be. That level at least you should achieve. So that is what I would say for Disha. No, who asked me this question? I don't know.
Ragendra ma'am.
Ragendra. So that is how you have to. It's a simple thing, but it's a right time for you. You are undergraduate students, or you have got into a good course in a good college. So I feel you should. And as somebody in the beginning said, you have to be strong and start studying and all. You have a lot of time now. A lot of resources are there in the internet. I wish you should. If you are fascinated, interested, you should start studying. Pick up slowly. Start with the basics and then get into one particular domain. And a lot of job opportunities are there in this domain. Even you can look at the different ways, different types of data. I mean, not the types, but the different, as I said, how this NoSQL databases, how it works, what are other forms in which this knowledge can be represented, other than maybe when you talk about data, you talk about the structured SQL, but there are other class of databases which are called as NoSQL. That means not only SQL, like the data can be stored in the form of RDFs or JSON objects, XML. They are semi-structured. Then unstructured data is there. So which file system can handle unstructured data? Then you have something which is called as integrated, like you have MapReduce, key value pairs models. You have document objects. Then you have Hive. Okay, so many other NoSQL databases are there. You must know about all those things, because when we are in the future, the data is not going to be structured data even right now, and the big data characteristics come in with the data. So you should know what are the ways in which the data is, as of now, what are the emerging technologies where the data is handled. So the querying also changes. Suppose you have a HBase or you have a Hive database, the way in which you query is also different. So some NoSQL databases you should know. So that is also necessary. How can we keep up with AI as it is updating day by day? You have to keep running to stand where my university earlier where I worked, they used to say, in order to update yourself, like in order to be where you are, you have to keep running. That is the situation. Every day you fall, like, see, it's a very good initiative that your college department ma'am has done, that you have talks like this. Okay, thereby even we get opportunities. When I wanted to talk about this, I was just going through learning other technologies. Similarly, this is one good initiative that college level they have done, that you have talks like this. Other than that, you people can actually spend 1 hour a week, and you can have like a Friday evening 1 hour, or Friday evening everybody will go off. Friday morning 1 hour session see, there are 45 students here. You can or 40 students or 30, whatever, pick up one topic and just talk about it simply. Don't think where it is going to be useful in life, but so many things you can discuss. Maybe you must even know what are the companies that are there in our field right now. So if I say who is the CEO of how many companies are there, not only that company which comes for placement, but there are companies who you can apply and try for internships and all. Google has got a lot of Google Cloud GCP platform is there, Google Cloud platform. They have a program which is called as Google Cloud Associate Program. So you can register yourself, you can find out how, because you get an access to real cloud environment. You don't have to purchase anything. So there is a procedure for it. You can request one of your faculty to register for GCP, Google Cloud Associate. So you will know how cloud works, how to assign a task, how to query. There is a tool which is called as BigQuery, Google Query. That is Google GCP has that tool. So you will understand how a querying works. For each query, what is the amount of money that you will need. For every task, they will charge you, but it's free of cost as for a student. So these kind of things you can talk about, you can initiate. It's all up to us. That is not like a news channel which directly gives you the recent news. It is all you are actually in the right age and right time. So what I think is you must form your own thing and then talk about newer things. Okay, so I'll ask you, what are the companies that are there? Who do you, which company is the number one in IT field now? You should be able to tell who is the CEO for that. Okay, what are the technology that's coming up? For as far as processors are considered, what are the companies? Cloud providers, what are the companies? Like that, you should know everything. Then technology wise, you can have discussions. It should be made as part of your interest. I think you are a good set of students, because the way you ask, I understand you are enthusiastic. So you can form a group on your own and just 10 to 15 minutes you can discuss on some topics. Some new programming language you can talk. Maybe you will not understand the whole concept, but at least you will know that things are there like that. I think I've answered. Know how to update day by day. That's.
Thank you so much, Judy ma'am.
Yes.
I'm very happy students have asked questions and you have very patiently answered them. Thank you so much. Now let us move on to the vote of thanks.
I've prepared also thinking that the presentation also, the technical level I have restricted because you have told me that they are students and the first time they are okay. So if they have further queries, they can mail or they can talk to me also. There.
Yeah, sure, ma'am. Sure.
Yes.
Ruhi, over to you.
Thank you, ma'am. Thank you, ma'am, for your words and for this session. Now I invite Anamika for vote of thanks. Anamika, over to you.
We have come to the end of the session. Let me take this opportunity to propose the vote of thanks. On behalf of the Department of Computer Application, let us place our heartfelt gratitude to the resource person, Dr. Judy MV, Professor, Department of Computer Application, CUSAT, who has spent some time by sharing her knowledge and information on the topic Accelerating Artificial Intelligence with GPUs. Thank you, ma'am. The department is grateful for our principal. The department is grateful to our principal, Ms. C.R. Lalita, who constantly motivates us to do variety of activities for strengthening the quality. Thank you, ma'am. Next, I would like to thank our HOD, Ms. Anita Aritas, who has organized such event to motivate us. Thank you, ma'am. I also thank the faculty members of our department for their cooperation and support. Thank you, teachers. And finally, I would like to thank all my friends who have participated actively. Thank you, one and all.
Thank you, Anamika. Failure is not opposite of success, it's a part of success. With this, we come to an end of our session. Thank you everyone for having your participation. Thank you and have a nice day. Participants may leave.